Bismillah ar-Rahman ar-Rahim. In the last part, we defined the inverse matrix. And we said that the inverse matrix can be found by A inverse equal to 1 over the determinant of A multiplied by the adjoint of A. And we said that the inverse, or B is an inverse of A if A multiplied by B equal to B multiplied by A equal to the identity. And we call the matrix A non-singular. A is non-singular. Non-singular means it has an inverse. We have some relation between the non-singularity of the matrix A and the determinant. And n by n matrix A is non-singular if and only if. If and only if the determinant of A is not equal to 0. So if the determinant of the given matrix A is not equal to 0, then A is known as non-singular. Which means that we have some matrices that have no inverse. If they are singular, then we don't have any inverse for that matrix. If the determinant is not equal to 0, then it is non-singular and we can find the inverse. For example, see. Determine whether the given matrix is singular or non-singular. For example, number 1. A is given by 1, 2, 3, 4, 5, 6, and 7, 8, 9. I need to check whether this matrix is singular or non-singular. Or what I need to find the determinant of this matrix A. And then you can determine whether it is singular or non-singular. Let's find the determinant. The determinant of A, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. We can use the cofactors method to find the determinant, or just simply we can duplicate the first and second column. That is 1, 4, 7, 2, 5, 8. This will give me the determinant of the matrix A. When upward, downward will give me the positive sign. This is positive. Multiply these three numbers, and with the positive number or positive sign is equal to, the first one is plus 1 multiplied by 5 by 9, plus second one, 2 multiplied by 6 by 7, plus 3 multiplied by 4 by 8. Now down to up with negative sign. Minus 7 multiplied by 5 by 3. Minus 8 times 6 times 1. Minus 9 multiplied by 4 by 2. Which is equal to, first one will give me 45 plus 2 times 6 times 7 is 84 plus 3 times 4, 12 times 8 is 96. Minus 7 times 5, 35 times 3 is 105. Minus 8 times 6 is 48. Minus 72. Add everything together, we'll have, this will be 180, 225 minus 225, which is equal to 0. Since the determinant equal to 0, this means that A is singular. It means it has no inverse. So this matrix has no inverse. Select another matrix, number 2. With that, B is given by 1, 3, minus 15. 0, minus 1 and 5, and minus 1, minus 2. Let's check the determinant for this matrix. Using the same technique, I have 3 minus 5, 15, 0, minus 1 and 5, minus 1, minus 2, 11. And to find the determinant, I'm going to duplicate the first and second column. It should be okay. With these parts. So this is positive. So determinant is equal to, I will have the first one will be minus 11. Second one, minus 15. 0. Now the negative one will be, this is 3. This is negative, negative, negative. So it will be minus 15. The next one, minus 10, minus 0. So this will be minus 26 plus 15 plus 10, which is equal to minus 1. Now minus 1 is not equal to 0. So the matrix B is non-singular. Is non-singular. So if it is non-singular, it means it has an inverse. The question will be how to find the inverse for such matrix. Now to find the inverse, we have two methods. The first one, A inverse equal to 1 over the determinant by the adjoint of A. That was discussed in the last part. Second method, to find the inverse for a given matrix, write the matrix using the augmented matrix. It is A bar I and convert to the matrix I A using the row operation. We have matrix A, so write the augmented matrix A I and convert it using the row operation to the matrix I to the left and other matrix. The right one will be the inverse of the given matrix A. To explain this in detail, let's find